Good morning, everyone. Today I'll be presenting a seminar on the topic streams, performance, mass storage structure, disk scheduling. So let's begin. Streams. Streams is a framework used in Unix system V to provide modular input or output processing. In simple words, streams allows data to flow between a user program and a device in a structured and flexible manner. And also, Stream allows developers to insert or remove modules between application and drivers. Let's look at the features of streams. First one, full duplex communication, which means data can flow in both directions at the same time. It can flow from process to device and from device to process. Next is message-based data transfer, and it supports networking, terminals, device input or output. And it's mainly used for characteristic device like terminals, keyboard, etc. And for network protocols, TCP and IP, and also terminal input or output. Okay. Next, look at the major components of streams. So, streams has three major components: stream head, stream modules, and device driver. Stream head. This connects the user program to the stream. It's the entry point for data coming from the application. Stream modules. These modules act like filters. They transform or process data as it moves through the stream. We can push or pop modules dynamically depending on the requirement. Now, device driver. This is the bottommost part of the stream. It interacts directly with the physical device, like a keyboard, terminal, etc. And each of the components contain a pair of queue, a read queue and a write queue. Data flow through these queue in the form of messages. So this is the structure of streams. As you could see, user process is connected to stream head, then read queue and write queue is in stream modules, and driver end is connected to device. I think this is very clear from the diagram itself. So now let's look at the performance, system performance. Okay, system performance tells us how efficiently an operating system is functioning. There are several important parameters used to measure this, like CPU utilization, throughput, turnaround time, response time, waiting time. Let's look into everything in detail. CPU utilization. This indicates how busy the CPU is. Higher utilization means the system is using the CPU effectively. Next, throughput. This refers to the number of processes completed within a given time. More throughput means better system performance. Next, turnaround time. So this is the total time taken to complete a job, from submission to full completion. Next, response time. This is the time taken for the system to start responding after the user submits a request. So this is very important in interactive system. Next is waiting time. So this is how long a process sits in the ready queue waiting for the CPU. So if you are looking at the factors affecting performance in OS, system performance is affected by many factors. CPU performance, memory performance, storage performance, input and output device speed, software optimization. So now let's talk about mass storage structure. So mass storage structure refers to device that store data permanently. It's used for long-term and non-volatile storage. Some examples are hard disk drive, solid state drive, USB drives, CD or DVDs, cloud storage that are logically. And features are stored OS, files, and application. It retains data without power. It's larger capacity than RAM. Okay, now let's talk about disk structure. There are two components like physical disk structure and logical. So in physical, we can see platters, tracks, sectors, cylinders, and read or write head. Platters. These are circular magnetic disks that store data, and tracks, circular rings on the platter. Sector, small divisions inside each track, and it is the smallest unit of storage on a disk. Cylinders, a group of tracks on different platters that lie one above another. I think it's very visible from the diagram shown here. Now let's talk about read or write head. So this head reads data from the platter and writes data into it. Okay, then logical disk structure. Uh, it has blocks, partitions, and file system. Blocks. A fixed size unit like 4 KB is used for file operations. Partitions. Divide the disk logically like C drive, D drive, something like that. Yeah, we can see in our system C drive, D drive like that. So this is the partition. File system such as ext4, ntfs, and etc. So now look how disk access works. The speed of disk access depends on three important times: seek time, rotational latency, transfer time. Seek time means the time taken for the read or write head to move to the correct track. This is the slowest and most important part. Rotational latency. Time taken for the correct sector to rotate under the read or write head. Transfer time. Actual time to read or write data. So we can see that disk access is equal to seek time plus rotational latency plus transfer time. By combining these three, we can see disk access time. So the next topic, disk scheduling. Many processes request data from the disk at the same time. So if the disk serves request randomly, the head will move a lot, which will cause slow access. So disk scheduling algorithm decide the best order to serve disk input or output request. So the main goals here are to reduce seek time, to increase in throughput, and reduce wait time and improve response time. So the major disk scheduling algorithms are five common algorithms. FCFS means first come first serve. SSTF, shortest seek time first. Scan, C-scan means circular scan, and look and see look. So let me explain briefly about disk scheduling algorithm. First one, FCFS, first come first serve. As the title shows about, the first come will be serving first. So this schedules requests in the order they arrive. It is simple and fair, but it does not minimize head movement. Next, SSTF, shortest seek time first. This select the closest request to the current head position. It reduces seek time, but can cause starvation for the for request. So, it take for shortest one first. So the far request will take more time. Next is scan, elevator algorithm. The head moves in one direction, servicing all requests on the way, and then reverse direction, like elevators. Elevator, as you know, like how elevator works, like that. Now, C scan, circular scan. The head moves in one direction and after reaching the end, jumps back to the beginning. This gives more uniform weight time, like circular. Now let's look and see look. These are optimized version of scan and C scan. The head moves only up to the last request instead of going to the extreme end of the disk. So disk scheduling is used in hard disk drive, database server, file system design, and OS kernel storage modules. So let's conclude. So here we understood that streams provide a modular way to handle input or output in Unix. System performance explain how efficiently the OS works. Then master structure describe how permanent data is, like it's a permanent data and it's long-term data for non-volatile. And disk scheduling algorithm helps in improving disk speed by reducing seek time. So all these will together helps the OS to run smoothly and efficiently. So that's all. Thank you.